Dear students, welcome back. This is Dr. Bijovadevan. This is the last video for your class 1. That is for week 15. We are releasing this video in advance. The only chapter that we are going to discuss this video is 4.8 Rolle's theorem. And refer your syllabus for final exam. The chapter 4.5 not included. Newton's method. So we ignore that one, right? So we have to discuss only 4.8 Rolle's theorem and mean value theorem. Rolle's theorem is a special case of mean value theorem. Let's start with the Rolle's theorem. What it says, a function is continuous, function f is continuous on the closed interval and differentiable in the open interval. Isn't this condition is given? Function is continuously going in the interval and is differentiable everywhere. There is no discontinuity. And at the end points, so the lower limit of function is 0. It means it crosses x-axis, and at the upper end the function again crosses x-axis. Then between these 2 points the function should turn back at least one point. At the turning point the derivation will be 0 because there will be a horizontal tangent line. Its angle is 0, slope will be 0. That is the meaning of Rolle's theorem, first derivation. So when this is not only true for whenever the function cuts x-axis, this is true for whenever this is x-axis and this is y-axis. If there is any other line parallel to x-axis, still the function intersects the same axis twice. That is, function value at the lower limit is equal to the function value at the upper limit, not necessarily be 0. Even for equal values, f of b equal to f of b, then there is at least one point, maybe more than one turns, at least one point at which the first derivation at the point can be c here against x. So at this point first derivative will be 0. That is the Rolle's theorem. So that is the corollary. The f of a is equal to f of b, not necessarily be 0 sometimes, isn't it? Then there is a point c, at least one point in the interval a b at which first derivation is 0. So geometrically, mean value theorem, this is a special case. Mean value theorem states that between 2 points, this is the point x value and the function value, so xy. Isn't it? So this the graph differential function of at least one place, at least at one point, the tangent line will be parallel to the second line. That's the point. At least one point. There will be more than one points possible. That's the second graph. So now let's move to the mean value theorem. F is a continuous function in the closed interval a to b and differentiable in the open interval. Always differentiable will be the open interval because the closed interval left limit of the derivative may not exist here, right? May not exist. So it's always open interval for differentiability. Then there is at least one point in the interval. See, at least one point, maybe more than one is also possible, right? Such that f dash first derivation at the c is equal to the average rate of change. So this statement is nothing but this right hand side is average rate of change, the left hand side is instantaneous rate of change, right? Rate of change, ROC. So what they say, when the function is continuous and in the closed interval and differentiable in the open interval, then there is at least one in the interval, at least one point c. Instantaneous rate of change is equal to average rate of change. Physically, what does it mean? We will take an example, right? You're traveling in a car in a highway. In this highway, the speed limit has been given as 110 kilometer per hour, right? Kilometer per hour. So at this point, you notice at this point by 10 o'clock in the morning, at this point you are crossing you have traveled 60 kilometers, isn't it? and now you're reaching this stage. Now you traveled totally 80 kilometers by 10 10. So you have reached some stage here, maybe it is 60 kilometers in your odometer, right? At that moment the camera noted down at 10 o'clock that you are here at some point, and you crossed 20 kilometers, and there at this point your odometer is showing around 80 kilometers. There the time is 10.10. no, the time difference is, if it is 0 then this 10 minutes, right? So the time difference is 0, so that is our limit a and b, 0 to 10, right? Now you traveled f of a is 60, f of b is 80. Now find the average rate of change. 80 minus 60 divided by 10 minus 0, which is 20 over 10, which is 2 kilometer per hour. So per minute, actually this is minute, 10 minutes. So convert into hours, multiply by 60. This 2 kilometer will be 120 kilometer per hour. What is the point? So your average velocity is 120 kilometer per hour. So at least one point in this road you might have reached 120 kilometer. So actual speed limit is 110 kilometer. So when you reach 120 kilometer, at least one point in this between these two stages, you can be booked for speed violation. That's the point of mean value theorem. Consequences of mean value theorem. If a function continues in a closed interval and differentiable in the open interval as usual, if first derivation is positive, then f is increasing. If first derivation is negative, then f is decreasing. If first derivation is 0, it is constant. Function is constant as usual. And then constant difference theorem. Okay, if you find two functions are differentiable in an interval and the derivatives of the functions are equal in the interval, then f minus d, the functions differ only in constant. One function is the constant is equal to sum of the function and a new function and a constant. So they differ only in the constant. Let's go to exercise set 4.8. Verify the hypothesis of Rolle's theorem are satisfied or not, and the given interval, and to find the values of c in the interval that satisfy the conclusion of the theorem. This is f of x. Okay, this is f of x. This is first problem, second problem. Okay, first problem I take, f of x is given. This is a and b. What is f of a? Use 3 here. 3 minus 24 plus 15. This is actually x square, so 3 square x square. You write on x square. 3 square is 9 minus 24 plus. So this is 0. F of a is 0. Now f of b, which is 5. B is 5. 5 square is 25 minus 8 into 5, 40 plus 15. So f of a is a equal to 0, which is equal to f of b. At the end points, the function intersects x-axis, isn't it? Therefore, f dash of c is 0. So what is f dash of x first? There is at least one point c inside the interval 3, 5, at which the first derivation is 0. That's the point, isn't it? The curve is turning at this point. Okay. F dash, when you differentiate this function, you will get 2x minus 8. Let f dash of c is 0. So instead of x, use c. 2c minus 8 is 0. So 2c is 8, c is 4. So c is 4 is the point lying between 3 and 5, at which first derivation is 0. So f dash of 4 is 0. That is, the conclusion is true. Second one. Let me try second one, isn't it? This is ln x. F of x is ln x in the interval negative 1 to 3. So first find f of negative 1, which is our f of a. Ln 4 minus 2 plus 1, which is ln 1, which is 0, ln 1 is 0, f of b, upper limit f of 3, ln 4 plus 2 into 3, 6 minus, oh I'm sorry, this is x square, the square is not shown in this, so this x square, 1 square is 1, so this square, 3 square is 9, so 10 minus 9, again it is ln 1 into 0. So f of a, the conditions of the Rolle's theorem have been satisfied. Therefore, there is at least one c in the interval -1 to 3 such that f dash of c is 0. So find f dash. First f dash of x, then we will take c instead of x. 1 over 4 plus 2x minus x square, and then differentiate the term, the inner term, which is 0 plus 2 minus 2x, isn't it? F dash of x should be taken to 0 to find the c value. To c value, denominator will be c, denominator will be x square, this is 2 square plus 2x x square, isn't it? Now take negative outside. Okay, take f dash of c is equal, f dash of c is equal to 0. Find the c value. Take it 0. You will find 2 is the common in the numerator. So if f dash of it is to be 0, only numerator is to be 0. So 2 minus 2x is 0. That is x. Instead of x, use c. So 2 is equal to 2c gives c is 1. So at c is 1, so f dash of 1 will be 0. We don't find a critical point. We want to prove f dash is 0. So only for 0, numerator should be 0, not denominator. Don't worry about the denominator. So f dash of 1 is 0. Rolle's theorem satisfied, right? Now another, check the validity of Rolle's theorem for the function. In this case, what is happening? This is f of x, is x square minus, this is f of x square minus 6x plus x, and find f of a, which is f of 0. This is 0 minus 0 plus 8, 0 minus 0 plus 8 is 8. F of b, which is f of 6, 36 minus 36 plus 8, again 8. So f of b is equal to f of a, which is not 0 but 8, isn't it? So still there is a point, and there exists a c inside the interval 0, 6 such that f dash of c equal to 0. That is Rolle's theorem. So differentiate f. You get f dash of x is 2x minus 6. So f dash of c equal to 0 gives 2c minus 6. Instead of x, use c. 2c minus x equal to 6 equal to 0. 2c is equal to 6. c is 3. c is 3. So conclusion is f dash of 3 is 0 by Rolle's theorem. Now we do verify hypothesis of mean value theorem. Instantaneous rate of change is equal to average rate of change. I will do it for one problem. This is x minus 1 over x. This is x cube minus x minus 4 negative 1 to 2. Okay, let me do 6 first. Find f of the function is continuous in the interval, differentiable in the open interval. Okay, then we have to find f of a and f of b. f of a is f of minus 1 minus 1 minus 1 minus 4, which is minus 6. At the upper limit, f of b, f of 2 is equal to 8 plus 2 minus 4. 10 minus 4 is 6, isn't it? So what does statement f dash of c, there is the one point c in the interval negative 1 to 2, at which the instantaneous rate of change, first derivation at C, is equal to f of b minus f of a divided by b minus a, isn't it? So what is f dash? F dash of x is 3x square plus 1. So f dash of c is 3c square plus 1. Substitute all the information here. This is 3c square plus 1. F of b is 6 minus f of a is minus 6. You know, b is 2 minus of minus 1. If f of a and f of b are equal, the numerator will be 0. Therefore, f dash will be 0. It will be Rolle's theorem, right? So here they are not equal, so it's not Rolle's theorem. What do you get here? Continue here. 3c square on the left side. 3c square plus 1 is equal to 6 plus 2. 6 plus 6 is 12 divided by 3. So you get 3c square plus 1 is equal to 4. 3c square is 3, c square is 1, c is equal to plus or minus 1. There are two values of c, but negative 1 will not fall. Negative 1 is the boundary point. So obviously 1 is in the open interval, isn't it? Because refer the theorem one more time. And the theorem states that where is it? In this open, there is at least one point in the open interval fb, so not a closed interval. Negative 1 is the limit, lower limit. So negative 1 should not be considered. C is, the answer is C is 1 at which this theorem satisfies, isn't it? C is, the value of C is 1. Now let's try last problem of this chapter. This is x minus 1 over x, isn't it? This is x cube. So what is f of a, upper limit, f of 3, lower limit, f of 3. 3 minus 1 over 3. What do you get? 9 minus 1, 8 over 3. F of b, which is f of 4. 4 minus 1 over 4. 16 minus 1, 15. 15 over 4. And b, this is a, this is b, right? So b and a. So first derivation, f dash of x 1 minus 1 by x square. So this is 1 plus 1 over x square. This is f dash of x. So f dash of c will be 1 plus 1 over c square. So by mean value theorem, what we get? There is at least one, there exists at least one point c in the interval 3, 4 such that f dash of c is equal to f of b minus f of a divided by b minus a. And f dash of c is 1 plus 1 over c square on the left side. Right side, f of b 15 over 4 minus 8 over 3 divided by 4 minus 3 is 1. So simplify this one, solve and find the c value yourself. You will get c is equal to plus or minus 2 root 3, and negative 2 root 3 will not be in this interval. Therefore the only value for c is 2 root 3. That's the end. That's the end of the problem. Thank you very much.